Hello to viewers, welcome to my channel Science to Technology. In today's show, Computer Wednesday, we're going to talk about Intel Arc graphics. So let's dive right into it. Now, what exactly we are talking about? You have to understand Intel is very familiar with graphics because they have been making iGPUs from the start. So they know what this is. And dedicated GPU is a newcomer, quote unquote, in the computer industry. However, it became the cool thing at this point in time. So lot of money is being created from GPU. Now, there is a common misconception people have is that GPU is for basically gamers. That's how it started. But right now, GPU makes a lot of money, not from gamers. Gamers are just like a test bed, basically alpha testers. And then these same graphics card, same basically chip is now packaged better and then sold to data centers. At that point in time, it prints money. So GPU started as a niche thing, add-on and all that. Just now it's starting being consumed in the render farms, and now it's being consumed in data centers, AI processing centers, because whenever you need insane amount of parallel data crunching, this puppy is the main deal. So fundamentally GPU went from something add-on to no, every supercomputer you see nowadays, unless it's built on something very specific, generally it will be CPU and boatload of GPUs. So GPU is a very big money maker at this point in time. And AMD and NVIDIA is king at this point in time. So if you're running on common operating system like Linux based kernel systems, generally you will be buying graphics card from either from AMD and NVIDIA. There are other companies that are making compute cards, but these are the granddaddy at this point in time. So there is a gap in the market because of pandemic. Pandemic triggered what we call a GPU crisis. Now, GPU crisis should not have happened. Any sort of chip shortage should not have happened. The reason chip shortage happened, it was like seriously bad mismanagement and demand increase. Now, because of the mismanagement, the time it took to recover became extremely long, and not to mention war also. So what created a scenario where you had people like specifically automakers who were the worst hit of that, like they reduced their orders. It's like instead of ordering for assumed X variable, they're like, how about X divided by 2? And companies are like, okay, but they sold that half component they got, they sold it to other vendors, other people who are making chips. Consequence was now the whole pipeline was booked, and it's like you were in a queue, now you left the queue, now you have to go back from the back. That same created an issue. So the GPU crisis became exponentially worse, and demand also went up because a lot of people are working from home, and randomly people discovered the giant old PC is not as effective. So a lot of demand started. Then again, Ethereum also happened. It also became very profitable to mine, specifically on new generations of GPUs. So there was a lot of gap in the market. Basically, AMD and GPU, they were just evaporating, meaning truck left the factory and it went poof. That's it. That those GPUs were never seen or heard from before. So there was a giant gap in the market, and demand was also growing. So fundamentally, even if you released a garbage product at that point, because the demand was so goddamn high, people were like, shut up and take my money. Shut up and take my money. So this was the perfect time for Intel to launch. So Arc was conceived, quote unquote. Now, you have to understand, Arc is a basic GPU, but it also has a lot of parallel technology added to it. Same way other graphics card also do. For example, if you're old enough, you remember there were a lot of parallel technology they wanted to add, like this decoding engine or physics X, like NVIDIA wanted to do. So like RTX, when you see about it, that's the parallel technology that was added to core GPU. So this company, basically Arc, also has hardware level ray tracing, exactly like how AMD did this generation. Now NVIDIA, when they did in Mark 1, basically RTX 2000 series, it was not that good because of two main reasons. First, it was a chicken and egg situation, because yeah, you made a graphics card, but unless it's a console, people are not developing for that graphics card specifically. So that created a scenario, because even though the games could be ported for RTX, nobody ported for RTX. Now there are game engines that are like now coming to with RTX support, and specifically because some consoles supported, now they are being ported. So that created a scenario. The first series, yeah, you have this technology, no use for it because no games use it, exactly like how physics X fizzled out. However, ray tracing, almost entire industry sort of agreed that we have to go here. So all consoles support it, AMD started to support it. So that created a scenario where if Intel came now without a dedicated hardware unit of hardware level ray tracing, it will not work. So they are like, okay, we just added that. Now Intel, again, they are a big enough company with enough experience. They are like, we're gonna give you AV1 codecs engine. Now AV1 codecs is a very complex codecs. Like if you're old enough, you remember like back in the days when you buy new DVD players, they had a saying like support H.264. H.264 was a very complex codecs. Now again, it allowed you to directly decode video file and audio video without any issue. And same way, like if you had a very old computer, you cannot run modern video files on it. You will not think about it. But if you are going back really old, you will find, dude, it's not working. Or even if you're playing a basic video on VLC, you'll notice your CPU usage is very high because it does not have the dedicated silicon to decode that video file. AV1 is the future's codec. Basically, think of this: the world is stuck at H.264. And this Intel is directly jumping to H.265 or 6. So H.265 also exists. It became popular with video, basically 4K Blu-rays, and 4K HDR Blu-rays wanted to use H.266, but that never came to be. Again, it's still using H.265. H.266 is not as popular, and in that gap, H.266 is not becoming as popular. AV1 became popular, and right now many things use AV1. So having a dedicated chip right now, so early on, is very advantageous. Like if you have heard people talking about like how can you edit videos on iPad, and they're saying, dude, it works much better than desktop. The sole reason for that is Apple took a big risk and directly put a media encoder chip specific, like basically put a silicon for exact format. Benefit: it works like butter, like milliwatts of power, where your desktop will consume kilowatts of power to do the same crunching. So that's awesome. It does have a consequence that if the format changes, let's say everybody switches from H.265 to H.266 or H.262 AV1, you will be stuck. That silicon would be wasted. So Intel took a very big risk supporting all these advanced codecs directly on die, silicon level support. That's a very complex thing to do. Deep link with Intel CPU is almost same as like how AMD had the advantage that there's a addressable BAL support will first come to AMD only, simply because again they control the hardware stack completely. The CPU was their control, GPU was their control, so they made sure the integration was flawless. Same thing here. Now deep link for you and me would not be that important, but for laptop manufacturer it will be like a godsend, because if they can dynamically adjust the power budget, they can get really good feeling performance rather than actually having the performance. So that's really awesome. Smooth sync, it's almost like a G-Sync variant again for Intel, butter like output. Now I'm not talking about core technology because it's a GPU. It's just these are parallel things they added just out of the back, meaning they are no longer in a world where they're like, okay, this is a graphics card. No, this is a graphics card that can do everything. So this is what they tried. What about the performance? This is where poop hits the fan. Flat out, it's not good. Flat out, the end, like if you ever wanted to worry about it, like how's the performance, flat out bad. Like even this performance where people are showing it's just a little bit less than 1650, it's like exaggerated beyond belief, simply because you have to understand there are way too many issues, way too many issues, and way too much unused tech. Yeah, it has a codex engine. What's the point of running a code, hardware streaming if your game is not running? Yeah, if your game itself is not working properly, what's the point? Yeah, I can encode parallelly without any issue. It's like, yeah, the game is not working. What's the point of encoding? So that's the issue. AI accelerator, media encoders, they are all unused at this point in time. And Intel is like really bad in this. Like I provided a video down below of the people who are working on the project. They're like, yeah, we made amazing technology, nobody used it because we did not market it properly. Like in this, Apple is really good. It's like, we're gonna make this technology, you're gonna love it. So those technology created an issue where the actual silicon, like the silicon is not cheap. So putting that codex engine, putting a new sort of system does take actual silicon, consumes money, and that increases your cost. And the core driver is flat out not stable, meaning even to achieve this, many people who are running benchmarks, people who have imported computers from China, they're like, dude, it's just not good. Flat out not good, not stable, artifacting issues to like, what the hell is this driver, to like, how the heck this can be this bad from a company that has been making GPUs from, again, you may be like, it's dedicated, not dedicated, but still a GPU. They still know how to deal with kernel. They know how to deal with Microsoft. It's like, how the heck it could be that bad? It's like really that bad. And old APIs are flat out not supported. Now that's a big issue, because even though Arc is like, Arc 3, Arc 5, Arc 7, they support DirectX 12 to complete extent, meaning complete 100% support of DX12 stack. Most games are not DX12. Like games, because again, I used to work in the game industry, like I worked in, like for example, Halo or Spider-Man, they were like years, like we used to get models, assets and all that, just start to work on it like 3 years advance, sometimes 4 years in advance. So generally technology is always lagging in games. So even if you have like direct storage, why the heck it's not there? Again, games that you are seeing now would have been worked at least 3 to 5 years in advance. So fundamentally you have to wait. So that created an issue. Like many games are still, like again, many popular games are DX9, many current games are still DX10 and DX11. Those are not supported well. So that creates many popular games, they are just not running well. So again, if you play with modern games, you can get good experience, but the moment you go to a little bit older titles, it's like, dude, what the hell? Again, stack is not stable enough, and system must have resizable bar support for FPS, otherwise your FPS will go YOLO. You will go from 60 FPS to literally 23 FPS, because again, the stack architecture is overflowing too much, so it does require readdressable bar between CPU and PCI Express lane communication to adjust for it. So fundamentally, it's really bizarre. Like, the performance output is really bizarre from a company that is this big in terms of capital, this big in terms of name, and this big in terms of experience. How the heck you can create something this messy? It's like, flat out, buy it only if you need AV1 codecs. Otherwise, like, stay away from it. Flat out, like, you can buy 1650. I'm not even talking about RTX. You can buy 1650 and you still will beat it. So that's a very serious issue. And there are some dark rumors. Now, the rumors are like, there is serious problem before this puppy starts to make money, because you can make this, you can sell it also, because again, there is a genuine demand in the market, and even if it's not very let's say performance, you can reduce the cost to such a point where people will buy it, or you can sell it at a loss. That's an acceptable business strategy. That's exactly how PS3 was launched, but it does not make money. Like, you can do it, it does not make money. So that creates a scenario. Now you have to understand, any other company that is working with you, for example, Asus works with Nvidia and AMD. Asus has to take a look at the company and be like, are you serious about this? Only then I will dedicate the pipeline, dedicated everything, logistics that I need in order to manufacture your card. So they require what we call roadmaps. So this is the roadmap of Intel series. So Alchemist, again, it's coming right now. Battle Mage is already under construction, meaning the physical silicon is being worked on right now. And the Celestial, the software design is being worked on, because again, if you ever looked at the basically chip design, the circuit that is inside here, that could be few terabytes or petabytes of again, millions of transistors. Again, it does take a lot of time to design also before you send it to fabrication lab for fabrication. So these are generally compulsory requirement, not compulsory as in like not required by law, but generally nobody will invest in you if they do not see you like, hey, you have a roadmap. And everybody knows, like everybody who has experience knows Mark 1 products are generally garbage. So same goes with Ryzen came out, and before they even came out, they were like, yeah, we are working on this and this and this, like, we are working on Zen right now. Zen 2, Zen 3 is the launch schedule. That's the reason. Now, problem is that flat out, they are not effective against competition at this point in time. They're not even close. They're just like, dude, not even close. Like, yes, it is true that ATI technology was not that competitive. It got sold to AMD. AMD took it, tried to polish it. It was not that good. But again, compared to anything else, it was a competition, and they slowly started to approach Nvidia. Now again, they are still behind, but they are approaching. Compared to that, Intel is just like third place. It's like, and not third place as in like, close to AMD. Third place as in like there is no fourth position. That's why they are in third position. So it's really bad in terms of competing. So how the heck they're gonna sell too much? Either they have to sell at a loss, or flat out, the worst case scenario, people will be like, dude, it's worthless. Like, I'm wasting a PCI slot, I'm wasting so much time, money, effort, and power supply. What the hell I'm getting? So that creates a scenario. And the worst aspect of it, the sole reason why Elon Musk never opens up SpaceX to open stock market, is that stockholders will not be kind to that. Meaning, stockholders can actually take you to court and be like, remove this person from company. Like, they are not running the company that makes the most profit. It's required by law. Now, many times profit requires you to play the long game. It's not going to be profitable today, but it's going to be profitable in 10 years from now. Companies no longer can do that anymore. Specifically, if you have a really large stock market footprint, stock market will like, they will like, no, you have to make me profit next month. So that creates a serious issue. Again, companies that are investing in large enough quantities, they are wise enough. They're like, dude, sometimes it takes time. But how long before they start to yell? ROI, again, ROI 1 or 2 years is acceptable. ROI for like, 5 years or 10 years, shaky grounds. So that creates a very serious scenario. Another aspect is, it takes a lot of money even to do this. Again, these are already made. These are just not sent to board partners. They're like, okay, if Intel already made it, why they are not sending it? Because they are stuck in a position. When the first chip came out, they assumed it has like some bugs. Of course, they assumed it, and then they started working on it. Once they actually started to work on it, they're like, damn, this is bad. As in, like, they thought like it will take 2-3 months to polish the driver. So like, people are like, damn, it's a good thing. It's like, no, we can spend years on it. Maybe at the other end we'll have a system that works. It's like there are some serious flaws in the design, and some people are saying is the flaws in the silicon itself, so it cannot be patched or fixed as you like. So even though actual physical chips have been manufactured, it has not been sent to Asus, HP or things of that nature. So a lot of money is already spent, and fabrication space is now in serious competition. Intel is not in a good position anymore. It used to be the granddaddy, but of course with the growth of TSMC, Samsung and other companies like that, they started to lose their market share. And not to mention, they lost a lot of big things. For example, mobile market, they lost. CPU market, even in enterprise, AMD is starting to take a chip. Then they lost a very giant customer known as Apple. So that created a scenario where they are no longer just Intel good enough. They're like, okay, we have this fabrication lab. We are making a new fabrication lab in USA. They're like, okay, that lab will be open to public. Meaning, if you are Samsung, if you're like, hey, I want some extra chips made, come to us. If you are like a RISC-V manufacturer, it's like, I'm using RISC-V for making this, come to us. So those fabrication space, meaning the place where you can make this, is now in very high demand. So at this point in time, it's like it's a double loss. You're not just losing money because you're wasting money on it, you're losing money because you could have rented this place to someone else. So right now there's a serious competition inside the company with other things and money makers. So that is like almost the same reason why Samsung F62 does not have OLED of Samsung. It's like, wait a minute, how the heck that can happen? OLED is generally manufactured by Samsung Display Technologies. I think it's semiconductor division, and the mobile is the public division, and they're like, they have to bid for it, like, sell us. They're like, no, the bidding was like too high. So they're like, okay, we buy from someone else. Yeah, it happened inside Samsung. So don't be surprised. This sort of thing is surprisingly common. If you ever worry why Sony disappeared from mobile market, Sony literally was fighting inside itself with Alpha division and Ericsson division. They were fighting. So Rumour is very serious at this point in time that Intel can actually axe this puppy. So what we can expect in the future? Well, from a personal point of view, from a company point of view, from a corporation point of view, more competition is good, flat out. Because again, those data servers, they also like that, dude, there are only two players. And again, if you are duopoly, you could end up in a scenario where like how camera industry was with Nikon and Canon. They were like, both were trolling the audience. What can you do? There was no third player. It's very easy to end up in a duopoly where you cannot actually do anything else. So everybody wants competition. Now, GPU is a very big computation platform. I specified it's not just gamers. It's a very big computation. The same chip, same hardware could be literally processing NASA data at this point in time. I'm not even joking. So it's very big. It's like from Intel's point of view, they're like, dude, that's a big crunch. We can make some serious money there. So it's a good target to have. Now, cancelling this project will reduce credibility of Intel. Now, Intel credibility at this point in time is not good. Again, losing something as big as Apple, not really good. Losing something as big as a CPU dominance from AMD, not really good. Having a history where you cancelled Intel Itanium, not really good. Trying to make a processor for basically ARM competition in mobile space, losing that also, not really good. So if you have this many black spots, if this many black patches, you create a scenario where credibility goes down. What does that mean? That simply means every time you have to raise capital, basically we are working on this unit that want to do this, company will be like, will not give you money for experiments, because again, most things are experimental if you are trying to expand yourself. So that creates a very serious issue where it could be limited because of this cancellation. They're like, yeah, we need let's say $1 billion to start investing in new technology. They're like, other investor could be like, do you remember how you cancelled Itanium? Do you remember how you cancelled ARC? Do you remember how you cancelled mobile division? Do you remember how you cancelled this and that? Again, they will not give you money. So that's a very serious issue. Your credibility matters. Like if you have never seen this Nikon photos, that's the same thing happens when you do not have credibility. If you keep cancelling products, it does have a very bad stain on you. Again, Apple does also cancel products. It's not like never happened. It's just like you have to make sure it's very rare. Like if you have 10-20 things, one thing maybe, and it's like it has to be shh. So you cannot have just this was the competition for GoPros very early on, 2016. They cancelled it. So. And again, look at it now. They have also cancelled their 1-inch sensor. They have also cancelled their Coolpix lineup. They have cancelled this, that, and now the whole company is being cancelled. So your credibility matters. From Intel's point of view, they are stuck in a very sticky situation. Yeah, they are losing money. Yeah, they have to be expecting to be like, yeah, we have to lose even more money. So it's not a joke. It's not an easy thing, but their credibility is at the line. If once you lose the credibility, you lose future. So fundamentally, it's not a very easy, not making money, cut it. That's how many companies disappear from the map, because many things require decades of experience, generations of elbow grease in order to work. For example, Rolls-Royce, they were about to go bankrupt. They literally hired their retired engineers to can you come here, take money, whatever money you want, just come back, fix our thing. And that's how they become the giants they are in the gas generator engines, meaning jumbo jet, high biflows engines. That's their puppy at this point in time. It happens. You do require credibility. You lose credibility, you lose capital raising support, and that's a very serious issue. And from a company's point of view, diversity portfolio is compulsory. You cannot just be in a say, oh, I'm only making CPU. Yeah, at this point in time, the way Intel is going, if they keep losing things, the at future they will be like, yeah, we're just a fabrication lab. Like literally, they will fall to the level of TMC, TSMC. Not good for a company that laid the foundation of computation at it is to be like, we just manufacture chips for someone else. Because again, AMD is taking care of x86 very well, even in server space, even in that. Apple already left you. You already pissed off a lot of people with Itanium. You already pissed off a lot of customers. And I'm talking big customers like Asus and other board partners, MSI and all that jazz. And like, with ARC burnout, you could literally lose because you will not have any diverse portfolio. Again, this is a new computation market. Why did not you jump into it? Yeah, we cancelled it because it was not making money instantaneously. So it's a very big issue. And let's be realistic. Mark 1 product is always garbage. That's real. Watch Iron Man Mark 1. Garbage. Always garbage. That's physics. You can't do anything about it. But if you have trust on your team and your own capability, it's a very bad idea to cancel it. If you have trust on the team, that's the whole aspect. Who is building the thing? Team. Do you trust the team? Because here's the deal. Same thing happened with AMD when they were trying to save themselves from the disaster of Bulldozer. I have that Bulldozer CPU. They created Ryzen. Ryzen was garbage on Mark 1. Like literally had random bugs that could brick the motherboard. That's how bad it was. But again, they pushed through. The Mark 1 was garbage. Mark 2, okay. Mark 3, you know what? It's a good multi-power. Mark 4, bro, literally going to Mark 5, yeah, bitch, please. So that happens. It's a common thing. It's a normal thing. Canceling everything just like, it's not making profit right now. Again, what else you gonna do? Your other ventures have not turned out well. The other ventures are really not turning out well. So canceling ARC is not wise at this point in time. Again, from my point of view. Let's see what happens in the future. So this was my presentation on basically Intel Arc GPUs. Hopefully you have liked it, learned from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free. And as always, thanks for watching.